Hi, my name is Steve Kendrex. I am the Senior Product Manager for AWS Batch here at AWS, and I'm here today to give you an overview of AWS Batch as a service and how it works, things that you can do with it, and why you should be taking a look at it. What is AWS Batch? Well, in 2017, we announced the launch of AWS Batch. Its purpose back then and now is to streamline running simple batch workloads in the cloud. And Batch is kind of a two-pronged product. It has two main jobs. It's there to schedule jobs, and it's there to launch and manage your resources, right? So as a job scheduler, AWS Batch controls and manages the job lifecycle for millions of jobs, from dependency and retry management to state monitoring. As an orchestrator, AWS Batch offers fully managed computing primitives for you, right? So we are able to provide you resources that are optimized for your workloads. So you only need to worry about the workloads that you need to run, and we will manage taking care of that compute resources. It evaluates when, where, and how to run jobs that have been submitted to the job queue that you create, and Batch manages for you. It provisions and scales the compute instances that are needed for each job queue, and then shuts down those instances and resources when those jobs are complete. It manages the job queues and workflow from start to finish, and with each job queue maybe, or in each kind of job definition, and we'll talk about that you are submitting, we will manage that mix of resources for you so that the right mix of resources is available to run the jobs on your behalf when you need them. Why should you look at AWS Batch? AWS Batch has been constantly evolving over the years to give you the ability to choose work, or to submit your work no matter what the workload is. Batch reduces the need for compute resource management. Again, as I talked about before, we handle the scaling of batch resources for you. It will provision the appropriate mix and the appropriate amount of resources for your jobs. It is integrated with other AWS services, right? So again, this is a cloud native orchestrator. We are fully and seamlessly integrated with services such as step functions, EC2 Spot, and even file systems, S3, and anything else CloudWatch that you maybe need to monitor and observe your resources with. It schedules and executes batch computing workloads across the range of Amazon EC2 compute. And before this, customers had been plugging together, up to 20 or more different services to try and manage both the queuing aspect and the scaling aspect of their workloads. It's in terms of optimized resource provisioning, again, I talked about this and I'll talk about that for more, but what Batch is able to do is it is able to factor in the cost of the resources as a calculation for providing you with a solution, right? So we can give you, based on what your jobs need, we can launch instances that are cost optimized and able to, reduce overall the amount of time that those instances are running, or, by bin packing, for example, by bin packing together jobs on machines, right, to reduce the overall amount of time that you spend scaling up and down instances, for example. We are also integrated with Spot, particularly as I'll talk about, tools that are used to maximize Spot availability by looking for the deepest capacity pools and assigning that to capacity pools within Spot and assigning that to your workloads. AWS Batch is a free service. You only pay for the AWS resources, for example, EC2 resources, file systems, other services that Batch launches on your behalf or connects you to on your behalf. So, right, this enables you to go from thinking about a CapEx model where you have to worry about deciding which instances are the best fit for your workload, or deciding what the best compute that you have to purchase for your on-premise cluster. You need to figure that out, look at your workload, say, okay, I need X mix of how much do I need to do to plan for peak to mean. Batch will handle all of that for you, so you don't need to, right? You can just focus on the workload that you need to get done. There's no undifferentiated heavy lifting. You get to focus, again, on your application, and Batch will take care of the queue, the job definition, the retries, the dependencies, and the instances underneath. All right, AWS Batch in numbers, just to give you an idea right now, we've had customers running up to 1.24 million vCPUs. We've had customers running 500,000 simultaneous job and container images in the same account. We have customers who are running container images up to 30 gigabytes and downloading those repeatedly, right? So that gives you the idea of the sense of scale that AWS Batch is capable of running. We have thousands of concurrent batch customers, some of who run the largest workloads in the world. If you start thinking about autonomous vehicle simulations or design automation or other sort of simulations, financial simulations, for example. Who uses AWS Batch? Well, here's a few customers using it. For example, the Quantitative Biology Center uses high-performance computing platforms to analyze genomics data and determine, for example, gene expression differences between diseased and normal tissue. Cubic, as it's called, and it's there on the middle left of the screen, is located at the University of Tübingen in Germany and supports genomics research with the university and other research organizations across the globe. Western Digital is a simulation described, right? And they use Batch, to run tens of thousands of tasks concurrently to help automate their design and simulation process. Fred Hutch researchers are engaged in the analysis of the microbiome, which is the collection of microbes on and inside the human body to make therapeutic cancer drugs more effective. And so in this case, Fred Hutch had to analyze a number of whole genome sets and microbiome samples using AWS Batch and EC2. They had a process that used to take, or at least, before the advent of cloud computing, right, where you had essentially unlimited resources. Sometimes these processes would take months or years to develop, and in this case, they were able to bring that process down to weeks. And those are just a few of the examples that customers can do, and you can pause the video here if you want and take a look at the other examples. When should I use AWS Batch? Well, there's a few reasons. AWS Batch is there to handle complexity for you, right? When you have job dependencies, retries, sometimes that queue mechanism can get very complicated. We will maintain that logic for you, so you don't need to worry about them. When the job is supposed to run, it will run. Synchronicity of jobs, for example, right? You know that you have certain work to get through, you need that to happen in a rapid turnaround time. AWS Batch can scale out compute resources for you and ensure that jobs are scheduled rapidly onto those resources so that you can get the synchronicity that you need in order to meet your business goals, right? For example, again, turning around a genome sequence that used to take you months and getting those results back in a week, right, can be very valuable. Cost integration, so cost either on demand or spot. We integrate with your reserved instances and capacity reservations so that you can you can take advantage of those on demand, but also we integrate deeply with spot, and so that we can offer you, as I talked about before, the spot capacity optimized strategy, which will enable you to lower costs and achieve interruption rates, right, that are reasonable for your work. File system integration and ease of setup, intelligent instance scaling, GPU support, of course, and the fact that AWS Batch will scale massively, but also scale to zero. You don't need to worry about instances that are sitting around, maybe as control nodes or sitting around, trying to process artifacts after the fact. When your work is done, right, Batch will get rid of those instances for you. All right, what are batch schedulers used for? Let's get a little bit back into it. So I talk about how AWS Batch is built to run in, built to manage things in a cloud native way. What is AWS Batch designed to do? Well, customers, and we start thinking about traditional batch schedulers, on-premise batch schedulers. They're built to maximize utilization of available resources, right? Utilization equals cost. do this as swiftly as possible while respecting user priority, right? Things like fragmentation, which is the underutilization effectively of instances, is a big deal because essentially while an instance is sitting there in not being used, right, that's money that could essentially be spent on other things. In the cloud, though, flexible capacity means that utilization is not important, right? Utilization itself isn't important. It's only there to measure, to be a measure of absolute cost, right? Absolute cost is what's really important. And the reason for that is, again, we're no longer in a CapEx world where we have purchased this up front and we just need to utilize them. And we are in a world where the instances that are running are costing us, and we need a scheduler that can manage, right, having those instances alive for as little as possible. Throughput requirements also changes, right? A traditional on-premise scheduler where you have a fixed number of resources or a mostly fixed number of resources, you need sophisticated scheduling techniques in order to maximize that utilization, right? But AWS Batch, and not just maximize utilization, maximize throughput, because essentially, if you have different users with different priorities, for example, and that high priority job needs to come in, then you need to start having sophisticated scheduling so that those high priority jobs can come in ahead. With AWS Batch, right, if you think about it, we can just add resources. And so as you have more and more work come in, you don't need to worry with and mess with scheduling algorithms so that you can figure out how to optimize, user A, who is slightly higher priority than user B, but only sometimes in some cases, but the other cases, user B gets priority. No, with AWS Batch, right, if you just add enough resources so that user A and user B can always run in parallel, then right, you don't need to worry about those things. Now, there are places where scheduling techniques have their place, of course, but the ability to handle cloud native concepts is more important. Why are many tools so bad at handling cloud scale workloads, right? Because many applications are only built, and tools and schedulers are only built for a largely homogeneous and stable world. Even if there are heterogeneous compute resources, those resources are stable. And the scheduler knows in advance what it has to work with and what it doesn't have to work with. But cloud workloads are heterogeneous, scalable, transient, and only growing more diverse. Heterogeneous workloads, right? An example, right? As customers onboard more and more work into the cloud and different, not just the single application. Maybe you start off with a single application, but as you continue to add more, maybe from different business groups, you start getting heterogeneous work. Right. Well, heterogeneous work and homogeneous capacity doesn't mix, right? So let's take an example here. Right. With let's take an example where you have a customer that has a single tenancy model versus a multi-tenancy model, right? And those are the kind of the two options that you have today very often, right? Or at least what we see very commonly happening is, so let's take we have heterogeneous work on the left, we have some CPU bound jobs, you have some memory bound jobs, and you have a mix, right? In a handling that, you can take that and go, okay, single tenancy, I'm going to assign each work item, or I'm going to assign everything into a single cluster, and that single cluster needs to launch M5 24XO. But as as we get there, we can start seeing fragmentation, right? Not all of the memory bound jobs can fit onto the M5 24XL. Maybe that one that has a mix, right? That fits together, but the CPU bound jobs and the memory bound jobs, maybe they don't mix properly, right? Or we can do things like, we can do a multi-tenancy, which is CPU bound jobs. I'm going to have a specific cluster that's created and it only has CPU optimized instances, memory bound. Let's say, okay, we're going to go put that into the multi-tenancy, into the R5s, and then the mix will be M5s. That's great, but now you have a loss of, not only do you have a potential loss of capacity if we're talking about things like the spot market, right, where there may not be that capacity, and especially when you're running high throughput, like a lot of our customers are, you need to think about your capacity picture in the AWS spot market. But there's also now you have to manage a multi-tenancy model. You have different clusters that you have to scale up at different times, and you have to manage those, maybe take one down to update it, right? It becomes much more difficult to manage. With AWS Batch, a lot of that work just goes away and it disappears, and we manage it for you. And we have CPU bound, memory bound, and mix. Right? And when we launch instances, right, and we can take a look at the job queue and look at the CPU to memory ratios, for example, and say, okay, listen, I need X amount of compute for these jobs, and run those jobs on the appropriate. And where we need to mix, for example, you see on that bottom one, we will launch different sizes of instances as well, right, all in a single cluster. And we will launch different sizes in order to, let's say, mix and say, listen, this memory bound job can fit on the M512XL next to jobs that are more mixed in their capacity requirements, right? So you can see how that management of the clusters, but also the management of the scheduling on to the instances that you have simplifies your world effectively. Now let's talk about how AWS Batch works. All right, so let's take an advanced example, which is image transformation. Right, so let's say that lands all into an S3 bucket, right? As users upload images, maybe, right? You have a little service that runs this. As users upload images, you want to run your image processing and put the processed image into an S3 bucket. Maybe you're going to do some transforming and paint them all blue or something, and put a blue filter or flip the image. That's actually surprisingly common use case. We just want to flip this image over. So you're going to initialize the process by setting up a job definition, which defines the operational characteristics of your job and any processing directives and scripts to run once the job is in process, right? So let's say in this case, you're going to have your job definition, right? That's going to contain your application imaging config, your roles and permissions. And once that job comes into that S3 bucket, let's say it fires off a Lambda function that submits a job, right? Or submits something, or triggers an event, maybe a CloudWatch event that then submits a job to AWS Batch. Those jobs are going to be submitted to the AWS Batch job queue, right? Where they will reside until they're able to be scheduled to compute resources. Right? And those are matched up and aligned with the job definition, so that Batch knows what this job, right, the resource requirements that job needs. Now, this is where the Batch scheduler comes in. That is managed by AWS Batch. That scheduler is then going to evaluate when, where, and how to run jobs that have been submitted to the queue. Looking at the vCPU memory and the vCPU memory and GPU requirements of the jobs determines that'll let it determine how many instances are needed and where to place the jobs. Jobs run approximately in FIFO order, right? The order in which they are submitted, as long as all the dependencies on the other jobs have been met, right? Batch will, and we'll talk about this in a little bit, Batch will manage those dependency graphs for you. Once the scheduler examines the number of jobs in your compute and launches instances into your compute environment, right? That managed compute environment is essentially where your compute resources live and and are managed by Batch and are waiting for resources, and then we put the jobs onto those machines for you. And you can choose specific instance types, instance families, or simply choose, right, that what we call optimal, and let AWS Batch launch just choose the instance families for you. So if you don't even want to learn, or you don't want to know about those, right, or have to learn about them, you don't have to, right? Batch will choose for you. When the job is finished, right, it successfully completes. Batch receives an event saying this job is finished. Okay, great. Right, that container exits, the resource is freed up for additional work, and of course the output, maybe you write it back into a job or to an S3 bucket. Right, and once those are completed, let's say that there's no more jobs left in the queue, Batch will begin terminating the instances in the compute environment when they are no longer needed in order to save you resources. So here's an example. Here's ways that you can control and manage queues and resources, right? So there are ways that you can manage batches scaling up. So we have things so if you see here, you have, it's essentially a user submitting job to a queue, and that queue is connected to two different compute environments, right? The instance types in each is optimal, and we don't have to worry about that, but you can set different ways for Batch to launch, right? Different ways for Batch to launch resources for you. For example, in this top compute environment, you have an on-demand compute environment. Maybe that's where your reserved instances are. And in the second compute environment, we have a spot compute environment. And what this setup is designed to do is say, listen, I know, right, I want to use my reserved instances first, right? I have 100 vCPUs worth of reserved instances, and so we're going to set up max vCPU to equal 100, right? And everything else additional I want to run in Spot for the cost savings. And so what happens here is that you say, okay, great, Batch will start evaluating that compute environment first, CE1 first, and we'll start saying, okay, I'm going to launch instances here. When I need more than 100 vCPUs worth of instances, right? And let's take the example that you have 101 jobs and each job takes one vCPU, right? When I have more than 100 jobs in this case, or I have 105 jobs, well, now I need to start launching instances into the Spot compute environment, and Batch will take care of managing those resources for you, right? So in this case, where one job equals one vCPU, if you have 1,000 jobs, right, in the compute environment, that's 1,000 vCPU, you're going to get 100 vCPU in the first compute environment and 900 in the second, right? And Batch will take care of making sure the instances that at launch are there to meet those requirements for you. There's different allocation strategies that you can use, right? For example, you can use for on-demand, you can use best fit progressive, and what that means is we will find effectively what we consider to be the best fit instance for you, and then we will progressively sort through that list to make sure that we reach the target capacity. And then on the Spot, we have Spot capacity optimized, which I've mentioned several times now is there to give you the capacity optimized instances, right, and sort by capacity, Spot capacity, so that we can make sure to reach that target vCPU. Combining these strategies, essentially, strategies, these different instance types, for example, allow you to set up your compute resources quickly and easy, but with enough flexibility to meet the requirements of your workload. Right? So we have some customers who say, I only want to launch one vCPU or one instance per job. Maybe I have restrictions somewhere else, so I don't want more than one instance per job. Well, you can do that by restricting the instance size, for example, or you can do different things. Say maybe I want minimum vCPU, right? Maintain a set amount of vCPU because I want those jobs to start as quickly as possible. And you can do that in the compute environment, right? So the compute environment is there to manage your instance scaling policies. All right, array jobs. So let's say you have, and now we're kind of getting back into the scheduling queuing mechanisms. If you have, let's say millions of jobs, it's not really viable to submit one job at a time, even API-ified, right? It's just going to take too long. Instead of submitting a large number of independent single jobs, Batch also supports a feature called array jobs. And not only is it that you have, a large number of jobs, but maybe you just want everything aggregated under a single job, right? Really, right? It's think something like a parametric sweep. You're really just doing the same exact thing every single time. And so what we do is we provide you a way to have many jobs that are all doing the same thing be aggregated under a single parent job, right? A single job that is essentially responsible in tracking the status of all of the children underneath. Right. So, for example, if I'm doing a Monte Carlo simulation or parametric sweep or processing a large collection of objects, I would do this, right? And you would have job, in this case, in this diagram, job A and job C are single jobs, but job B is an array job. Now, how does this work, right? So what are the different ways that you can do things? Well, if you're familiar with traditional on-premise schedules, this is what you can do. Right? You can do a job which depends on another job. So, for example, on the far left, we have job A running, right? Job A will run and job B is going to wait until all of the children from job A run. And then and let's assume that in this case, job A1 fails, well, the entire array. Now, the rest of the children are still going to run to completion and output results, but because A1 fails, right, there's no need. We already know the reason we set this dependency is because I don't want to run job B if A1 fails, right? So if A1 fails, the entire array fails, and there's marked as failure. And then once all the children complete, the entire parent will be marked as failure. Job B will not run. because it has a dependency. Let's go to the second example, right? Array job depends on job. In this case, it's just the same, but reverse. Job A is going to run, and then after that, maybe it's a pre-processing step, and then after that, the array job B will run. You can also have different array-specific dependencies. For example, with array jobs, you can have an end-to-end dependency. And what this is essentially saying, okay, job A and job B, job A 0 run, and then job B0 is actually dependent on A0, right? But they're isolated dependencies, which means that let's say that job A is taking forever. It's taking an hour to run, and job A0 is taking an hour to run, but job A3 is only takes 10 minutes. Well, B3 can run after job A3 is complete. It doesn't have to wait for A0. So you can get work done while maybe one element of the array is taking longer, right? You can also set up a depend on self, right? A sequential job. And that's the last example there where job A1 is dependent on A0, right? It won't run until A0 is done, and then job A2 can run, and then job A3 can run, right? So there are different models here. And what you can do with this is you can set up different combinations of models, right? For example, you can have the setup job, which is an isolated job. You can have a sequential job that might be maybe, let's take an example, the IO step, and that's a sequential job that is depending on self. So B1 is running after B0 completes. Once that entire array successfully completes, then we launch job C, right, which is end-to-end dependency on job D, and then after that, job E and F are running. But the good thing with Batch is that you can submit all of this at the same time and just essentially express your dependency, and Batch will take care of it for you, right? So Batch will take care of making sure that the dependencies are met, and we won't launch resources for you unless those jobs are runnable, right? So for example, in this case, let's say that job B, which is a depend on self job, is taking a long time to process all 10 jobs that are in it, right? Well, there's no point in launching resources for job D yet because there's no way that job D can run. And so we won't launch those resources until we know that those jobs are runnable, right? So we worry about those, that handling of instances for you. Now, you don't need to use, obviously, AWS Batch alone, right? We have integration. A very common use case is a natural, it's just that a natural fit for workflow managers, right? So you have AWS native and you have third-party open source, right? AWS native would be something like step functions. Third-party open source would be something like an Airflow, a Nextflow, a Metaflow, right? Those sorts of common workflow managers. Because essentially, let's take an example, the case where you need to integrate different systems together, right? I've got a I don't know, I've got some heavy, machine learning workload that need to be running on SageMaker that is separate from my machine learning workloads that are running on AWS Batch, right? And so once those work, but the SageMaker jobs are still outputting data that Batch needs, the Batch jobs will need access to. And so Batch, let's say this, maybe SageMaker is producing the model, and then we're going to run iterations on it with Batch. So you can manage that with one of these workflow managers, where you have essentially the step functions, for example, is checking to see the state of the SageMaker job, right? When that model is finished getting trained, now that model is produced. Okay, let's trigger the Batch jobs to run iterations on the model and check it and for validity, right? So that's a perfect example of what you can do with one of these workflow managers. And Batch is integrated with all of them. As a matter of fact, it is the primary compute layer for Nextflow and Metaflow when running on AWS. So, and so there is quite good integration. All right, in terms of traditional tightly coupled HPC, right? So AWS Batch does have support for MPI workloads, right? Multi-node parallel is essentially what we consider that if you think MPI or distributed deep learning. And of course, if you are familiar with MPI workloads, you know that you might need more than one compute instance to scale up, right? And so what AWS Batch will do, right, you submit a multi-node job and we will run that same instance management process for you. We will also give you all or nothing scaling. So let's say that we are running, we don't give you any instances until we know that we can give you all of the instances of the node group. So if you have 100 instances that are needed for your node group, for your cluster, we will give you, we won't partially scale up for you, right? We will scale up everything, right? And again, it's there for cost optimization, right? It's integrated with the Elastic Fabric adapter for low latency interconnecting between the nodes, right? And so, we support, the common MPI architectures, Intel MPI, Open MPI that you would need just just the same as any scheduler. Here's an example of deep neural network training. For example, right, you see underneath the covers, we have Amazon S3 using an Amazon FSx for Lustre. That's a separate talk file system. And that Lustre file system is now essentially, feeding the data into your cluster, right, which Batch has spun up for you. In this case, we have P3DN container instances, right, and Batch has spun those up in a placement group for you, right, it's spun up all four at the same time, right, and then up top, maybe you have your TensorFlow registry that is the source for the containers that AWS Batch is launching for you. And then on the right here, you just see an example of a nice linear scaling graph, which is what you like to see as you add more nodes. You want to make sure that that graph is, as close to straight as you possibly can, right? So that as you add more nodes on later on, we don't see any performance drop off. All right, so that has been a high level overview of how AWS Batch works and what we can do with you. Thank you for your time. Please reach out if you have any questions. Send us an email, contact us. There's ways to contact us on the AWS Batch homepage. You can see customer references. You can see different use cases on the website. All right, thank you.